Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with three symmetrical orthographic views which happen to be front view, top view and the left hand side view. And we can observe that into the three views, the shape of the object which is available with us, it happens to be symmetrical. Now as we observe the solid, we observe that the length of the solid happens to be 45 millimeter, while the height of the solid, it is also equal to 45 millimeter, and the width of the solid, it is also equal to 45 millimeter. So we are going to observe that the front face of the solid, it will be measuring 45 millimeter by 45 millimeter. The top face of the solid, it will also be measuring 45 millimeter by 45 millimeter, and the left hand side view face of the solid, it will also be measuring 45 millimeter by 45 millimeter. And all these inclined surfaces, they happen to be located at a distance of 15 millimeter from the corresponding vertical edges or the corresponding horizontal edges over here. So this way, these 2 points, they will be located in this case at a distance of 15 millimeter from the bottom and 15 millimeter from the left. Similarly, over here, again, the orientation of this inclined surface will be 15 millimeter from the corner points over here. So this way, we are required to obtain the 3D isometric projections corresponding to this engineering object when the front view, top view and the left hand side view orthographic projections, they have been provided to us. So in order to obtain the isometric projections of this object, now whatever true length dimensions they are available with us into the orthographic projections, so those true length projections we are required to obtain alongside this true length scale over here, which is drawn at an angle of 45 degree. And now the vertical projectors from the true length scale onto the isometric length scale we have to obtain, so that the corresponding isometric length dimensions, they can be obtained over here. Now once we have obtained the isometric length dimensions corresponding to the true length dimensions available with us into the orthographic projections, then we will observe that onto the isometric scale we have to mark length of the solid alongside the z-axis. The width of the solid we are going to mark alongside the x-axis, and the height of the solid we are going to mark alongside the y-axis over here. So the front view face will be located alongside the YZ plane. The left hand side view face of the solid will be obtained alongside the XY plane, and the top view projection corresponding to this solid will be obtained alongside the XZ plane over here. So this way we know that all the three dimensions, they happen to be identical. So the length of the solid will be equal to 45 millimeter. The width of the solid will also be 45 millimeter, and the height of the solid will also be equal to 45 millimeter. So now with this information, we have to proceed to evaluate the orthographic projections corresponding to this engineering object. As we know, this is a symmetrical object that we are required to obtain into the isometric projections. Since the length, width and the height of this particular solid, it happens to be equal to 45 millimeter. So all the three faces, that is the front face, top face and the side face, will be square faces which is going to measure edge length as 45 millimeter. So in this case we are going to obtain the projections of the outer boundary of the solid represented as a cube over here. So now we can check the height of the object, it is equal to 45 millimeter. The length of the object we have marked alongside the z-axis equal to 45 millimeter. Now we see that this is going to be our front view face over here, and this is going to be our left hand side view face over here. The width of the object we have plotted as 45 millimeter alongside the x-axis over here. Now, if we complete the construction of this cube over here, so now we will see that all the three faces we are able to obtain into the isometric projections over here. So we can check the front view face. It is going to be represented like a square having edge length is equal to 45 millimeter. Similarly, the left hand side view face, it is going to be represented as a square having edge length is equal to 45 millimeter. And the top view face of the solid will be represented once again like a square which is having edge length is equal to 45 millimeter. So this way we have been able to obtain a cubic projections over here which is going to represent the outer boundary of this engineering solid. Now we know that from all of the corners we have to move 15 millimeter in either direction so that these inclined surfaces they will be obtained alongside front face, top view face and the left hand side view face over here. So we know that from these four corners of the left hand side view face we need to measure distances of 15 millimeter from the corner points over here. Similarly, into this front view face from these four corners, once again we are going to mark 15 millimeter from each one of these corners so that we should be able to locate the corner points corresponding to the inclined surfaces over here. So same procedure will be repeated corresponding to the top face, in which from these four corners we are going to mark distances of 15 millimeter each from each one of these corners alongside the two edges which are going to constitute that particular corner over here. So let us mark the distances of 15 millimeter from each one of these corners over here. So now we can check alongside the front view length dimension over here. We have marked distances of 15, 15 and 15 over here. Similarly, alongside the front view height dimension over here, which is measuring 45 millimeter, again 3 points we have been able to locate corresponding to distances of 15 millimeter each over here. Now we can mark the points alongside the z-axis onto this isometric edge, onto this isometric edge and onto this isometric edge. Similarly, corresponding to the y-axis, again we have been able to mark 2 points over here so that we are able to divide this height of 45 millimeter into 3 sections which are going to measure 15 millimeter each over here. And alongside x-axis also, now we have marked the distances of 15 millimeter each alongside this edge length of 45 millimeter over here. Now we are able to divide this edge length of 45 millimeter into 3 segments which is going to measure 15 millimeter each over here. So parallel to x-axis, these are 3 isometric projection lines. Corresponding to z-axis, these are 3 isometric projection lines. Corresponding to y-axis, these are 3 isometric vertical projection lines over here. So since this object happens to be symmetric, and we know that how do we obtain the orientation of these inclined surfaces over here. So now once we have marked these points, now we can join these points into the top face. Now we will see, now we are able to obtain an octagonal shape into the top face projections of this solid over here. Similarly, corresponding to the left hand side view face, we are able to obtain the octagonal projections onto the left hand side view face over here. And finally, corresponding to the front view face, we have been able to obtain the octagonal projections represented onto the front face of this particular solid. And finally, we can join this edge, we can join this edge, and we can join this edge over here, so that we are able to obtain the completed 3D isometric projection corresponding to the engineering object for which the front view orthographic projections, the top view orthographic projections, and the left hand side view orthographic projections, they were available with us. So this way we have been able to convert the information which was provided to us through the three isometric views into a single 3D isometric projection view, in which we are able to obtain front view face projections, the left hand side view face projections, and the top view face projections into a single 3D isometric projection view over here. So this is all for today. So we are going to continue with further discussion regarding few more illustrative cases of isometric projections in the coming lectures. So thank you very much. Thanks a lot.